In today's class, we will discuss exercise 2.1 of class 10th Maths NCERT book. Now here, you are given few graphs of polynomials, and by looking at the graph, you should tell the number of zeros for each polynomial. For that, remember, you should always check the x-intercept of the graph. That is, you have to check how many times the graph touches the x-axis, and that will give you the number of zeros for the given polynomial. Now, the first graph, you can see here, it's a straight line. Does it touches the x-axis? No, not at all. It's not touching the x-axis at all. So, there are no zeros. So, this polynomial have no zeros. Clear? Okay, now let's move to the next graph and check. Now, this polynomial, it's touching the x-axis here. It's touching only one time. So, how many number of zeros will it have? It will have only 1 0. And now let's check here for the third graph. It's touching how many times? Let's count. Once, here twice, and here thrice. So this polynomial is touching the x-axis 3 times. So what will be the number of zeros it have? 3. Clear? Okay, let's move to the next graph. And here it's touching 1 time, 2 time. So the number of zeros it will have is 2. What can you say about this graph? So here it's touching once, twice, here it's 3 time, and here it's 4 time. So this polynomial is touching the x-axis 4 times. So the number of zeros it will have 4. What can you say about this graph? So let's count. 1, 2, 3. So this polynomial is touching x-axis 3 times, means it will have 3 zeros. Yeah, so this is all about 2.1. In today's lesson, we will discuss exercise 2.2 first sum. Find the zeros of the given quadratic polynomials and then verify the relationship between the zeros and the coefficients. Now let's understand some basic concepts. The standard form of the equation, quadratic equation, is ax square plus bx plus c, where a is the coefficient of x square, b is the coefficient of x, and c is the constant term. Now, if alpha and beta are the two zeros of this polynomial, then the relationship between the zeros and these coefficients are given as the sum of the zeros is equals to minus the coefficient of x over coefficient of x square. So what does that mean? Sum of the zeros. So the zeros are alpha and beta. The sum is alpha plus beta is equals to minus coefficient of x is what? It's b over the coefficient of x square is a. So this is how we will find the relationship. Now let's see the product of the zeros. So the product of the zeros is equals to the constant term over the coefficient of x square. So the product will be alpha into beta is equals to the constant term is c over coefficient of x square is a. So by finding the sum of the zeros and the product of the zeros, we can verify the relationship between zeros and coefficients. Now let's solve the sums. The first question here is x square minus 2x minus 8. So find the factors of minus 8. So it will be 4 2s are 8. So it's minus 8 means it will be minus 4 and 2. So let's write here x square minus 4x plus 2x minus 8 let's take common x. So x minus 4 plus let's take 2 common here. In the bracket we are left with x minus 4. So x minus 4 and x plus 2. Equate these two factors to 0. So here we will get x plus 2 equals to 0. So x is equals to 4 and x is equals to minus 2. So 4 and minus 2 are the two zeros for this polynomial. Now let's verify the relationship by finding the sum, that is alpha plus beta is equals to minus b over a. Now what is the let's find the values of a, b and c here first from the given polynomial. The value of a, see, value of a, there is no numeric value here, so it will be 1. So a is equals to 1, b is equals to minus 2, don't forget to take the sign, and c is equals to minus 8. Let's substitute the values. Alpha, let's take this 4 plus beta is minus 2 is equals to minus, what's the value of b? That is minus 2 over a is 1. So it will be 4 minus 2 and here minus and minus will become plus. So we will get 2. 4 minus 2 is 2. So our left hand side is equals to right hand side, hence verified. Now let's take the product. Alpha into beta is equals to c over a. Alpha, let's take 4, beta minus 2 is equals to c. The value of c is minus 8 over a is 1. So 4 2s are 8 with minus sign and minus sign 8. Left hand side is equals to right hand side. Thus we verified the relation between the numerical, the coefficients and the zeros. Let's move to next question, that is 4s square minus 4s plus 1. Now here you have to find the factor of 4. So it will be 2 2s are 4, but middle term is minus 4. That means by adding I should get minus 4. So it will be minus 2 minus 2. So let's find the zeros of this polynomial. 4s square minus 4s minus 2s plus 1. So taking 2s common here, we are left with the, let's write it here again. 2s common, we will get 2s here minus 1. Let's take here minus 1 common, so it will be 2s minus 1. So 2s minus 1, 2s minus 1. So the zeros we get is s is equals to 1 by 2 and s is equals to 1 by 2. So here are our two zeros for the given polynomial. Now let's verify the relation between the zeros and the coefficients. So for that, let's write the values of a, b and c. The value of a here is 4. The value of b is minus 4 and the value of c is 1. So the sum of the roots alpha plus beta is equals to minus b over a. And here it's 1 by 2 plus 1 by 2 is equals to minus, and value of b is minus 4 over 4. So let's take the LCM here. It will be 1 plus 1 over 2 and here minus and minus will become plus. So 2 over 2, what you will get? By cancelling and reducing, we'll get 1 is equals to 1, that is left hand side is equals to right hand side. Let's find the product. Alpha into beta is equals to c over a. Now 1 by 2 into 1 over 2 is equals to c. The value of c is 1 and the value of a is 4. So 1 over 4 on the left hand side and 1 over 4 on the right hand side. Hence, relationship is verified. Let's move to third sum. And here, okay, now this polynomial is not in the standard form. What's a standard form? That's x square plus bx plus c. So what you have to do is you have to rearrange the terms. So 6x square minus 7x minus 3. And here you have to find the factors of minus 18. So let's start. 2 9s are 18 and 3 6 are 18. Now you should select that factor in which by subtracting you should get the middle term, that is minus 7x. So we will go for 2 and 9 and the factors will be minus 9 and 2. Okay, let's write here 6x square minus 9x plus 2x minus 3. And here we will take 3x common. So 3 2s are 6 and 3 3s are 9 plus 1. So here it will be 2x minus 3. So 2x minus 3 and 3x plus 1. So the two zeros of this polynomial will be, here it will be 3 by 2 and here it will be minus 1 over 3. Now check it, the relationships. Alpha plus beta equals minus b over a. So what's alpha plus beta? 3 over 2 plus minus 1 over 3. So what we will do? We will directly write it 3 over 2 minus 1 over 3. And let's write the values of a, b and c. The value of a from the polynomial is 6 and the b is minus 7 and the c is minus 3. See, you have to get the values from here. The one that you from the polynomial which you get from after rearranging the terms. So here it will be minus b. So minus of minus 7 over a is 6. Correct? Okay, now let's solve this. 339, 2 over 326. So minus minus plus 7 over 6 and by solving the left hand side we'll get 7 over 6. Hence verified. Now find out the product of the zeros alpha into beta c over a. So it will be 3 over 2 into minus 1 over 3 equals, what's the value of c? Minus 3. Substitute the value of a, that is 6. So here 3 and 3 will get, is it 3 over 2? And this is minus 1 over 3. So it will be minus 1 over 2, correct. Now reduce this. So 3 1s, 3, 2s are 6. So it will be minus 1 over 2. So this is how we find the zeros and then we check and verify the relationship between the zeros and the coefficients. Okay, now see here. Here we have the term like ax square plus bx plus c is missing, that means c will be 0, correct? Now because we don't have the third term, so we can't find the factors by splitting the middle term. So what we will do here, what's the common between the two terms? It's 4u is common. So what is left behind within the bracket? It will be u plus 2, correct? So let's write 4u equate separately. Here u plus 2 is equals to 0. So here the first u is equals to 0 and u is equals to minus 2. So these are the two zeros that we get for this polynomial. Now let's verify the relation. Alpha plus beta is equals to minus b over a. So what's your alpha and beta? 0 plus minus 2. And now what is b? The value of b from the polynomial, find out, it is a. 8. Let me write here 8 over a is 4. So it will be minus 2 on the left hand side and 4 1s 4, 2. So minus 2 on the right hand side. Thus left hand side is equals to right hand side. Now let's find the product. Alpha into beta is equals to C over A. So it is 0 into minus 2 equals C is what? 0 over 4. So it will be 0 on the left hand side and 0 on the right hand side. Clear? Let's move to the next sum, that is the fifth sum. T square minus 15. Now you see, if you again check and compare it with the standard quadratic equation, you don't have the middle term here. Correct? So what we will do here is, we write 15 as root 15 square? Yes, because we know root 15 into root 15 will give you 15. So now you see, you can write this in the form of an identity a square minus b square. And what is that? A minus b and a plus b. Yes? Okay. Now let's write this now. T minus root 15 and t plus root 15. So we'll get two zeros for the polynomial. T is equals to root 15 and t is equals to minus root 15. Now let's verify the relation. Sum of the zeros is equals to minus b over a. Now let's see here. What's the value of a? That will be 1. The value of b, 0. And the value of c is minus 15. Correct? Okay. So here alpha plus beta. What is alpha plus beta here? It's root 15 minus root 15. Correct? So that will be equals to minus b. What is minus b? It's 0 over 1. So 0 equals 0. Let's find the product. Alpha into beta is C over A. What's alpha? That's root 15. And what's beta? That is minus root 15. So it will be root 15 into root 15. It will be minus 15. Now what's your C? C is minus 15 over A is 1. So right hand side is also minus 15, and hence we verified the relationship between the coefficients and the zeros of the polynomial. Now this is the last sum, and let's find the factors of 3 4s are minus 12. So what are the factors of 12? It will be 2 into 6 and 4 into 3. But we will go for 4 into 3. Why? Because by subtracting we should get the minus 1. So let's write here 3x square. It's plus 3x minus 4x minus 4. Let's take 3x common. So we'll get x plus 1 minus 4 common. So it will be x plus 1. So we get x plus 1 and 3x minus 4, and the two zeros we'll get is x is equals to minus 1 and x is equals to 4 over 3. So these are the two zeros. Now verify the relation. It will be x alpha plus beta minus b over a. Now minus 1 plus 4 over 3 equals minus b. B is minus 1. A is 3. So let's simplify this. Minus 3 plus 4 over 3, and it will be 1 over 3. Now you see here minus minus will become plus. So left hand side is equals to right hand side. Hence verified. Let's do the product also. So alpha into beta is C over A. Alpha is -1. Beta is 4 over 3. Let's solve the left hand side first. It will be -4 over 3. The value of C is -4 and the value of A is 3. So, here again it's verified. So, what we should know in this exercise, it's very easy. The first thing that you should know is the factors. How to find the factors of the given polynomial by middle term split. Alright, that's it for today. Thanks for watching. Let me know if you want me to cover anything else, and don't forget to like, share and subscribe.